Okay. Thoughts on how to start the warm-up? Like we got.
Change the tangent and cotangent to sine over cos times cos over sine.
Okay, so sine over cosine. This one becomes cosine over sine. There's other ways to start it. It's a good first look. Nice. What happens when we do that? Yeah, so cosines cancel, sines cancel. What does it cancel to? 1. It cancels to 1. So it's not 0. It's not like it's gone. It's 1 itself. Not quite. Okay. Next step. Turn that into sine squared. Yeah, so this is a true statement, but we can't stop here. This is one of our Pythagorean identities. We want to just go ahead and replace. We could replace either side with the other one. If we do it that way, then it counts as the honors way. Did anyone start this a different way? Or do this a different way? Or really starting it? What's a different way I could have done this? Here we go. Oh, yeah. So 1 minus cosine squared is sine squared. For our list here. That's this one there. From our Pythagorean identities. Yeah. So we replaced all of that with sine squared. Saba, what do you got? Okay. Yeah, I would say it's different enough. It's a different method. Instead of changing to sines and cosines, use a reciprocal identity instead of a quotient identity. And similarly, we could change cotangent to 1 over tangent. I mean, yeah, of course, the same thing is going to happen. It's going to become 1 there. So from now on, these two things are reciprocals. If they're multiplied together, they're always going to cancel to 1. So if you want to just skip the step of rewriting it and just go straight to 1, that is fine. Proofs are still pretty new, so you might not remember that right away. But same thing if I had like sine times cosecant. What does that equal? 1, yeah. That's not on our like formula sheet anywhere, but those are reciprocals. It's like if you have x times 1 over x. Anything times its reciprocal always equals 1. That's math. Okay. Let's go over the homework. Questions from the homework that we want to do.
Number 8.
Number 8. All right. The people have spoken. Number 8. Okay. All right. Number 8. So does tangent plus cotangent equal 1?
No.
No. Tangent times cotangent. Okay, so we can't do that. Thoughts? How do we start? What do I do? What's something I could do? Mike.
What I do is that I just added put sine, cosine, plus cosine, and cosine plus sine in the same fraction.
Where are you getting sine and cosine from?
From the tangent.
Okay, so tangent is, yeah, so let's break that down into a couple steps here. So tangent is sine over cosine. Cotangent is cosine over sine. Do we want to do anything on the other side? 1 over cosine. And 1 over sine. Okay. On the left, or sorry, on the right side, one thing that I think will be helpful is combining those to just make one fraction. So they're fractions being multiplied together. You just multiply across the top, multiply across the bottom. So we've got one thing. So here's something. I'm just going to move that up there. This is kind of like a good strategy to think about. Oh, no. Okay. What would we say are some differences between the left and the right side?
cosine and sine are on the denominator on the right.
Okay, yeah, so we've got denominators. The denominators are different. Yeah, one's cosine sine, one's just cosine, and one's sine. Okay. What are some other key differences? Think of the structure of the two sides. Okay, yeah, we got addition versus, well, even, yeah, this is just one thing. Right. So let's think about math for a second. If I have two things that are added together, what do they become? One thing. They become a single thing, right? So what we're doing here is addition. So this is like a key thing you want to notice. Like I've got two things added together on one side. I've got one thing on the other side. I need to figure out a way to add them. Now, that's not 2 and 3. I can't just add them straight up. But what could I do in order to add them? Yeah, common denominator, yeah. So this is a common denominator shows up a lot in this homework. You may have noticed. What is our common denominator going to be? Yeah, cosine times sine. So it's kind of like when you have 2/3 plus 4/5. I would need to multiply this one by 5/5 and this one by 3/3. I need to multiply by the denominator of the other one. So this one gets multiplied by sine over sine. And this one gets multiplied by cosine over cosine. But the key strategy that I want you to notice is like, because sometimes it can feel in a proof like whatever I'm doing is just arbitrary. Like, oh, Mr. Brownrigg knows what to do because he's a math teacher and he does this all day, every day. Which is not true. I do other things too. But I want us to see the logic of like, oh, we're trying to add. Right? In order to add, we need a common denominator. So this becomes sine squared over cosine sine. The order doesn't matter. It could be sine cosine or cosine sine, but just to match that one, like Brandon said. And now what can I do? Yeah, now we can add them together. That was the whole point, so that we can add them. Okay, and can we do anything else? Yes, this equals 1. That is our OG Pythagorean identity. So now we just have 1 over cosine sine, which is the other side, so we're done. If we wanted to do this the honors way, I could just change this into secant, cosecant. Or I could just stop right here one step before. It doesn't matter. Remember, we have an option to do either. Questions on that one? Okay, other questions from the homework? Questions going what? Oh, okay. Number 6. Okay, and I will say too, if you had trouble with number 5 or number 6, they're pretty much the same exact proof, like in terms of the steps. So this will also tell you how to solve number 5. Thoughts on how to start number 6? We've got some options. What ideas do you have? Remember, one of our key strategies is just to try something, anything. Great. Okay, change the secant to cosine. All right, so there's 2 ways that we can do that. I'll show you which way I prefer. So first is I could just substitute in 1 over cosine inside that fraction. And it kind of ends up looking like this. From there, I could go this route, combining those 2 things, like they're being multiplied together, so I just combine them to 1 fraction. This, again, can look kind of confusing. I'll tell you how I would rather do it. If there's a secant on the bottom, Right now, that means we have 1 over secant right now. So that secant can be rewritten just as a cosine on top. And so the left side could look just like that. We can take that secant on the bottom and move it to the top of the fraction, and it becomes a cosine, which is a lot easier because now I can see, oh, this is cosine squared over sine. Do we follow that? And the key is, like, we have 1 over secant. It's right there. That is the same as a cosine. So we can move that up to the top of the fraction, becomes cosine, gets me to cosine squared. That is the same thing that we would get from this. By the way, these two things are equal. I would say this way here is a little more complicated, so I would rather do it the other way. So I'm just going to clear some space and do that again. So that moves up. And then that becomes cosine squared over sine. Okay. I would say, we've done a lot over there on the left side. There's maybe more we could do. Maybe we want to go to the right side. No right answers here. Or no, just one right answer, I'm going to say. Thoughts on what we could do next? Paula? Yep. So cosecant into 1 over sine. Okay, now here I'm noticing again something very similar to that last problem. We got 2 things subtracting each other on one side, and on the other side I've got 1 thing. Thoughts on how to condense those 2 things into 1 thing by subtraction? What are we going to do? Brand?
Use the cosine squared to convert to 1 minus.
Okay, yeah, so we could change this into 1 minus sine squared. And now what that does, the advantage of that is now there's subtraction on both sides. So now both sides are starting to look a lot more similar. Yeah. I want to think of something I can do on the right side here. So. Yes, okay. So, again, not the only way to do it, but typically when you see things being subtracted or added, you want to find a common denominator. That's going to make life a lot easier. Multiply that by sine over sine. That is just going to show up a lot. And so we've got 1 minus sine squared over sine. I could finish the proof right here. I could just split the fraction on the left side if I want. And I can finish right there. There's a lot of different ending points we could have gotten, right? But I wanted to make sure we saw common denominator. Number 5 is almost identical. Other questions? No, you can't. Great question, but no, you cannot. Okay, so let me clarify why. Let me just take it back a step here, where it might be a little more clear that we would want to do that. So a normal ending point for this one would be like this here. Question of can we cancel out the sign on both sides? The reason is no, because then that means we're doing the same thing to both sides, which is our number 1 rule of things we're not allowed to do. So canceling out the denominator on both sides, not allowed. Because what you're really doing is multiplying both sides by sine for that to happen. And we're not allowed to do that. We're only allowed to do that when we know that something is true, not when we're trying to prove that it's true. Good reminder. Other questions? Mike?
Number 5.
Number 5. So number 5 is going to be the same process. I'm not going to do that one, but yeah, you can follow along. Very, very similar. Yeah. Other questions? 15. 15, we were supposed to skip that one. 15 and 16, we skipped. We'll come back to those today if you're not. Other questions? Okay. What I want us to do is go back to the notes and finish. Morning.
So I'm gonna give a sequel.
So I remember I told you guys to leave room for a total of 9 of these things here. We're gonna figure out what those are right now. Actually, alright. You know what I'm gonna do is I'm gonna rewrite these. Actually, you know what? We're fine. Okay. So we're gonna add some more of these down here. I'm gonna put our first one over here too, just so we can see it. This is our original one. And we started with number 1. We came up with numbers 2 and 3 by subtracting sine squared from both sides and subtracting cosine squared from both sides. We are allowed to do that because we proved that sine squared plus cosine squared equals 1. We proved that that's true right here on the right. So we're allowed to do the same thing to both sides. So now I'm going to do something that's kind of crazy. All right. Just for fun, I'm going to divide everything by sine squared. I'm going to do it to both sides, and I'm going to do every number. Feeling crazy. Thursday vibes. What is sine squared divided by sine squared? 1. What is cosine squared divided by sine squared? Cosine squared over sine squared. That would be cotangents. Yes, cosine over sine is cotangent. Cosine squared over sine squared is cotangent squared. And what's 1 divided by sine squared? What's that? Cosecant. Okay, so so we have now a totally new version of this. 1 plus cotangent squared equals cosecant squared. And again, we did that by just dividing everything by sine squared. We can do similar operations like we did to get number 2 and 3. I could subtract 1 from both sides to get cotangent squared equals cosecant squared minus 1. Or I could take the first one and subtract cotangent squared from both sides and get cosecant squared minus cotangent squared equals 1. So we get one new one, but we have kind of 3 versions of it. Go ahead and write all of these down. Make sure I want you guys to have a list that's complete list. When you memorize these, you could just memorize one of those 3, but I want you guys to have a list in your notes with all of them. Reminder that all of these identities will need to be memorized eventually. Okay. Well, now I kind of feel like I'm on a roll, and so I should do something else crazy. Now I'm going to take that original one and I'm going to divide by cosine squared. Subtracting. Which one? Number 6?
Number 5.
Number 5? Number 5, I subtracted 1 from both sides. Number 6, I subtracted cotangent from both sides. Okay, so I divide everything by cosine squared. What is sine squared divided by cosine squared? Tangent squared. Cosine squared divided by itself? 1. And then 1 over cosine squared? Secant squared. Okay, notice that these two are very similar looking. I'm going to switch the order of the second one just so that they match. I'm going to change it to 1 plus tangent just so they look the same. It doesn't really matter. It's the same thing. But I just want you guys to see the similarity. So 1 plus tangent squared equals secant squared. If I subtract 1 from both sides, I get tangent squared equals secant squared minus 1. If I subtract tangent squared from both sides, then I get secant squared minus tangent squared equals 1. Which brings us to a total of 9. Okay, so from those groups of 3, as you're memorizing, pick 1 from each group to start with, and then use that to figure out the other versions. The more you work with it, the easier the other ones will come to you, but those are going to be very helpful.
How do we get from 6 to 7?
From 6 to 7. We did not go from 6 to 7. We went from number 1 to 7. We divided everything by cosine. Yeah. Cosine squared. So we took the original one. We subtracted sine squared. We subtracted cosine squared. We divided by sine squared. We divided by cosine. Okay, so using that list of 9, I want you guys to do on the homework from last night, numbers 15 and 16. I'm going to tell you, you ought to use the list. It's going to make your life a lot easier. Ready, set, go. All right, so like I said, we want to use that list. That list is going to be really, really helpful. In number 15 here, do we see anything that's on the list? Sine squared plus cosine squared. Oh, that's literally the first thing on the list. What does that equal? 1. 1 plus tangent squared equals secant squared. Is anything from there on the list? Oh, yeah, that is on the list. 1 plus tangent squared equals secant squared. Yes, that's straight from the list. We can't stop here. We need to substitute. But yeah, that's it. Okay, so let me just look back at the list real quick, just to. So we used that one and that one. There they are. All right. Number 16. Is any of that on the list? What?
Minus cosine squared or is sine squared?
Okay, that's sine squared. Yep. Oh, and this is cosecant squared.
See, cancel over one.
Yeah, those are reciprocals. We can just go straight to 1 equals 1, or if we want to show a middle step, that's fine. This would be sine squared times 1 over sine squared. Okay. So we're using, where is it? This one. 1 plus cotangent is cosecant. And then we use this one. 1 minus cosine equals sine. So yeah. So one thing that will help, I'm just going to clear these other notes out of the way so we can just see the list here. Condense a little bit. We got this list of 9 things. What is something that everything on this list has in common? 1 and squared, being squared, exactly. Okay, so that's going to be a key. When you see like numbers 15 and 16, everything here is sine squared, cosine squared, tangent squared, secant squared. Oh, it's all squared. Okay, now I'm thinking this is probably from the list. 1 minus cosine squared. Oh, there's the 1. 1 plus cotangent squared. Probably from the list. So those are just little indicators that you're going to do something from this list here. Something to help you memorize it. So this one, everyone finds this one easier to memorize because it's just sine and cosine. It's the one we started with. You have an extra day to practice. Sine and cosine go together. Of the other ones, this group here have the cos. Cotangent goes with cosecant. If you remember that group goes together, it can just help you a little bit, little memory trick. It's not really, I don't know. Yeah, a helpful hint. And then, so the other one, it's got to be secant and tangent, those ones that are left over. I do have another memory trick that I'll tell you guys next class. I'll tell it to you now, and it'll be too much information you won't remember. Last thing I want to say about these is that there are some times when we're looking at a proof and we get something that looks a lot like something from this list, but actually isn't. So for example, cosine squared plus 1. Is that on the list? No. What about negative cosine squared plus 1? Is that on the list? Yeah, it is. That's the same as this, but positive cosine squared plus 1 is not on the list. Cotangent squared minus 1. Now, we've got cotangent plus 1. We don't have cotangent squared minus 1. Okay? So, just because you see something squared doesn't mean it's going to come from here. The more familiar you are with the list, the easier that's going to be to tell the difference. Here's a tricky one. There are some things that aren't on the list exactly, but we can actually use the list to help. Turn to your partner. What does cosine squared minus 1 equal?
Negative.
Wow, that was fast. Yes, negative sine squared. Okay, it's like we've changed the signs for both. We've multiplied it by -1. We would do that on the other side. So this is the negative version of 1 minus cosine squared. Which really means that our list actually could have 18 different things with all the negatives. We're not going to do that. It seems like a bit much. But keep that in mind. Keep that in mind. Okay. That's it for notes.